Dear students, today I would like to discuss the anomalous properties of fluorine. I am Dr. Digna Varghese. Fluorine exhibits a number of anomalous properties both as an atom and as a molecule. We know chemical symbol for fluorine is F and its atomic number is 9 and its mass number is 18.998, that is approximately equal to 19, and fluorine is discovered in 1886 by the great scientist Henry Moissan. We know the atomic number of fluorine is 9 and its electronic configuration of fluorine is 1s2, 2s2 and 2p5. Fluorine is highly reactive due to it has only one electron lesser than the inert gas configuration, so it can readily accept one electron to 2p orbital and complete its octet from other elements. Fluorine, is it a gas or is it a solid or is it a liquid? Fluorine is the lightest halogen and exists as a highly toxic pale yellow diatomic gas at standard conditions. Fluorine is a pale yellow green gas. Fluorine, what about its abundance, occurrence, odor and color? Fluorine is the 13th most rich element by weight in the crust of the world, and fluorine is obtained mainly from the mineral fluoride or fluorospar, that is calcium fluoride, and other fluorine bearing minerals include cryolite, sodium aluminum hexafluoride, and apatite, calcium fluorophosphate, and topaz, that is aluminum silicate containing some fluorine, hydrated fluorine. And fluorine is a poisonous pale yellow gas and it is sometimes fluorescent. Its odor is pungent smell, and fluorine is present in volcanic gases and thermal waters. Physical properties of fluorine. Physical properties of fluorine can usually be observed using our senses or involve a numerical measurement. We know it's a pale yellow gas. The phase changes, the fluorine can be changes to gaseous state to liquid state, and it can sometimes be fluorescent. Solubility, in liquid form it is freely soluble in liquid oxygen and ozone, and it has a density of 1.8 into 10 raised to minus 3 gram per centimeter cube, that is measured at 20 degrees Celsius. Its melting point is minus 219.6 degrees Celsius and boiling point is minus 188 degrees Celsius. Atomic radius, as we have discussed already, that is 64 picometer, and it has many isotopes, that is 17 known isotopes, but only fluorine 19 is stable and naturally occurring. And first ionization potential of fluorine is 1680.6 kilojoule per mole, that is due to its small size and a poor shielding effect. And the second ionization potential, that is always greater than first ionization potential, that is about 3134 kilojoule per mole, and the third ionization potential of fluorine is 6050 kilojoule per mole. Ionization potential, the order is third, ionization potential greater than second, then than first. The standard reduction potential, it has the most positive value among halogens, that is 2.87 volt, so it acts as the highly oxidizing agent or most powerful oxidant among the halogens. Anomalous properties of fluorine. Fluorine differs from the rest of the members of halogens. This is due to its small size. We know fluorine atom has a small covalent radius of around 64 picometers. The atomic size of fluorine is very small compared to other halogens due to its atomic number, that is only 9. So the number of quantum shells decreases, and high shielding effect compared to other halogens. Second reason is high electronegativity. Fluorine is the most electronegative element. We know the electronegativity value of fluorine is 4, and high ionization enthalpy. The first ionization enthalpy of fluorine is 1681 kJ per mole. This is due to its high shielding effect and a small size. And the fourth reason is non-availability of valence shell d orbitals for bonding purposes. Hence, the covalency of fluorine rarely exceeds 1. Here, in the case of fluorine atom, there is no d subshell. So, it cannot exceed the covalency from 1. Fluorine is the most reactive of all halogen due to its lower value of fluorine-fluorine bond dissociation energy, that is 158 kJ per mole. We know the bond energy is equivalent to the term bond dissociation energy, and it is the energy needed per mole to break a particular bond. The unusual weakening of the fluorine-fluorine bond is due to the relatively large electron-electron repulsion between the lone pairs in fluorine molecule, where they are much closer to each other than in the case of other halogens. Fluorine is the most electronegative element, and its value is 4. It shows only an oxidation state of -1 and does not show any positive oxidation states due to the absence of d orbitals in its valence shell. Other halogens show positive oxidation states of +1, +3, +5, +7, etc. We know fluorine is the most electronegative element, and also it has no d subshell, so it shows only -1 oxidation state. But other halogens show positive oxidation states. Due to small atomic size and high electronegativity of fluorine, hydrogen fluoride undergoes a strong hydrogen bonding, while other halogen acids do not. Other halogen acids like HCl, HBr, HI, but HF undergoes strong hydrogen bonding. What is hydrogen bonding? Hydrogen bond results from the attractive force between a hydrogen atom covalently bonded to a very electronegative atom such as fluorine, nitrogen or oxygen, and another very electronegative atom. It is a bond between a more electronegative atom and a hydrogen. Due to the high strength of hydrogen bonding in hydrogen fluoride acts as a liquid at room temperature, while other halogen acids are gases at room temperature. Hydrogen fluoride is weakest of all the halogen acids due to its high strength of hydrogen fluorine bond. That means in hydrogen fluoride there is a strong hydrogen bond interaction occurs. Due to this, it is a weakest acid among all other halogen acids like hydrogen chloride, hydrogen bromide, hydrochloric acid, hydrobromic acid, hydroiodic acid. Okay. The salt of hydrogen fluoride is different in several aspects. We know silver fluoride is soluble in water, while all other silver halides like silver chloride, silver bromide and silver iodide are insoluble in water. But calcium fluoride is insoluble in water, that is fluorspar, while other halides calcium chloride, calcium bromide and calcium iodide are soluble in water. This is silver fluoride. Silver fluoride is white, but in the pure form it is brown in color. Hydrogen fluoride cannot be stored in glass bottles since it reacts with silicates to form fluorosilicates, while other halogens do not react with silicates and hence can be stored in glass bottles. In our lab, hydrochloric acid is keep in glass bottles, but we cannot store hydrogen fluoride in glass bottles because the hydrogen fluoride, hydrofluoric acid, reacts with glass to form fluorosilicates. That is, sodium silicate is a glass material and that is reacts with hydrogen fluoride and forming fluorosilicates and water. Fluorides have the maximum ionic character. For example, aluminium trifluoride is ionic, while other halides of aluminium are covalent. Aluminium trichloride, aluminium tribromide, aluminium triiodide, these all are covalent in character, but aluminium trifluoride is ionic. Of all the halogens, fluorine has the highest positive electrode potential, that is its value is plus 2.87 volt, and it is most easily reduced and hence act as the strongest oxidizing agent. So fluorine is the strongest oxidant. It brings about the highest oxidation of other elements with which it combines. For example, sulfur. We know sulfur reacts with the fluorine to give sulfur hexafluoride, SF6. In sulfur, the oxidation state of sulfur is 0, and in the compound sulfur hexafluoride, its oxidation state is plus 6. So it is oxidized the sulfur. Fluorine is oxidized to sulfur, and in the case of iodine heptafluoride, iodine converted into iodine heptafluoride, it's an interhalogen compound IF7. In this, the oxidation state of iodine is plus 7. Other halogens do not bring about the highest oxidation state because their standard electrode potential is very low compared to fluorine. For example, sulfur and chlorine gives SCl4. That means it oxidation is like only plus 4. In HCl4, the oxidation state of sulfur is plus 4, and bromine gives only SBr2. The oxidation state is only of sulfur to plus 2, and iodine does not react at all. So the oxidizing power of halogens is like that: fluorine greater than, chlorine greater than, bromine greater than iodine. So fluorine is the most powerful oxidant or oxidizing agent, that it can even oxidize inert gases. inert gases like xenon, krypton, radon. Okay. Due to the absence of d orbitals, fluorine does not form polyhalide ions. What is polyhalide ion? A chemical compound of metal halides and halogens. While other halogens forms polyhalides of the type I3 minus, Br3 minus, I5 minus, etc., but do not form or does not form F3 minus, F5 minus, F7 minus, etc., because the absence of d orbitals in fluorine. Chemical properties. Toxicity. It is a highly poisonous in elemental oxidation state. It does not combine with the oxygen at room temperature. That is its oxidation. And compounds, the importance of fluorine lies largely in its compounds because it is highly electronegative and highly reactive, and due to its low bond dissociation energy, and it is highly corrosive gas. When mixed with the water, it reacts explosively. Reactivity with the elements, like it react with all elements. That means fluorine loves all the elements except helium, neon and argon. Reactivity with the heat, it is heat resistant. Fluorine is flammable gas. Okay. Some common applications of fluorine is used in toothpaste, and in trace amounts it is added to water supplies, and it is used in the extraction of uranium, and it is used in air conditioning and refrigeration. It is used to make insecticides and the common Teflon coating pans. Teflon is polytetrafluoroethylene. That's all about anomalous properties of fluorine. Thank you.